Howdy, this is your friendly neighborhood physics teacher, and I'm here to go over a few key points for your energy, work, power, and thermodynamics test that you either have Wednesday or Thursday. So, some major key points is 1, make sure you go over your quiz. Your quiz has some very good questions that we might like using. So make sure you go over your quiz problems. That is a yes, you must do. Go over your quiz problems. So that, definitely know your equations. Going over on your review, looking at question 42. I know that is looking over what variables go with what name and then go with what unit. That is very important to know. So those are the two big ones. Now, so I'm just going over a little bit of concepts. So you have a system and it's losing energy. So basically what that means, so if you have a system, you have a set of total energy. So let's look at this equation right here. So mechanical energy, which is your total energy, equals your potential energy plus your kinetic energy. In a perfect system, this all stays the same. No matter if this goes up or if this goes down, whatever, this stays the same. That's in a perfect physics world. So this only happens in a perfect physics world. Okay, perfect physics world. We don't live in a perfect physics world. So certain systems can lose energy. There's certain things that you can lose energy by. Friction, so for losing energy, lost energy. So for losing energy, a couple of things that can lose energy is friction, sound, heat or thermal energy, it's the same thing. So friction, sound, thermal energy, those are the big effector, things that affect an object to lose energy. So think about a ball rolling down, you have a ball rolling across the floor. So if you have a ball rolling across the floor, in a perfect world, it would just keep going. Let's just keep rolling, rolling. Yeah, in a perfect world, it would just keep rolling. Well, again, like I said, we don't live in a perfect world. So eventually it would stop. And what's causing it to stop? Yep, you guessed it, friction. And so, yeah, you're like, well, I hear it, but yes, since there is friction, friction does cause your thermal energy. And so that just kind of all ties together. So I'll make sure you understand that concept. And also going back to your potential, your total energy equals your potential energy plus your kinetic energy. That's a big part of it. Also, remember, in a perfect physics world, and in which most of our problems are in a perfect physics world, your mechanical energy, which is also your total energy, it stays the same. Now, on your review, question 33 is a great problem to look at for that one. Okay, so now that's kind of, make sure you know your power equation, make sure you know your work equation, all that. Again, that ties in with your knowing your quiz. Going over your quiz. So yeah, you have all those key points. Now going into thermodynamics, when you have in a system, so we're just going to make a box. So this is our system. Anytime the system changes energy, so anytime it changes energy, guess what we're doing? That's your internal energy. Yay, anytime your system changes energy, it's going to end up doing work. And this is where this equation from. So if you change energy, you're going to end up doing work. The only time heat even plays a part is if you're adding heat into the system. Heat added. So if there's no heat added, you don't need Q at all. So you just do your delta U equals your work. And remember, your delta U is, delta means change in. So that's just your final minus your initial internal energy, and that will easily get you to your work. Another thing dealing with heat transfer is think about, remember we talked about, and this is in your Kahoot, temperature. It's pretty much goes hand in hand with kinetic energy. Goes hand in hand with kinetic energy. So the higher the temperature, the higher the kinetic energy. Because think about it, when you're starting going from a solid to a liquid to a gas, if you go back to that PhET simulation we played with, the molecules moved a whole lot more when it was in gaseous state than it was in solid. So again, as so this, your temperature increases, so does your kinetic energy. So make sure we understand that. Next thing, let's talk about way heat is transferred. We have conduction. Conduction, I could spell. That deals with touch. It's a basic way to remember that. Conduction is touch. We have convection. Big thing about convection is it happens in a fluid. It happens in a fluid. So remember, that could be a liquid or gas. And then, of course, radiation. Radiation happens with no particles. No particles, and even particles get in its way. It does not like particles. Okay. Particles get in its way really bad. It doesn't like particles. So conduction is touch. Convection moves around in a fluid, or so that's liquid or gas. So think about boiling water on that one. And radiation, you think about your sun, but it travels with no particles, and actually particles get in its way. Is a big thing about that. Trying to think of any other key points. Again, think about how heat transfers. Heat always wants to go from hot to cold. So that's how heat moves. Again, that's on your Kahoot, which is on your red folder where you found this video. That's all about the key points. Again, going through your review, I'll show the key to the review in just a minute. Going through your review, going over your quiz, your thermodynamics overview is always a good thing to go over. I guess my last hint is for the bonus question. It's going to be very similar to on your review, like number 41, but it's going to go backwards. So, we went from solid to liquid to gas. We're actually, on the test, it's actually going to go backwards. So on test, it's going to end up going backwards. So we're actually going to end up going from gas, liquid to solid. And that's going to result in a negative answer. Okay, so that's going to result in a negative answer. So think about it. The one we did it on in class and on the review, you're adding up your Q's, and the Q's are all positive because it's gaining energy. It's gaining heat. Well, this one is losing heat. So that's why your Q will end up being negative. You're still adding all your Q's, but all your Q's should end up being negative. So yeah, let's see, I promised I would show you the key to the review. If I can get there, here we go. So here's the key to the review. I'm just gonna slowly scroll so you can just check it out. And you know, of course, this is a video. You can pause at any point in time that you would like. Need some like background music as I'm scrolling. Of course, I'll hit some key points. So 10 is kind of like how we got a negative Q on 10 because it, lost, it says its energy is removed. It lost energy. That's going to be kind of like your bonus, but of course, you'll do all 5 steps instead of just the 2 steps on there. Again, make sure you know how to use all your equations. Make sure you know your laws. That's why I didn't go over. Make sure you know your laws. So your 0th law is the equilibrium law. Your first law is energy cannot be created or destroyed. Your second law is the law of entropy, the law of chaos. And your third law is the 0th law. So don't forget about those also. Let's speed this up just a little bit so the video is not so long. You can pause at any point in time you would like. Again, if you have any other questions, feel free to email Ms. Heath or Ms. Verona. You can also come in during tutoring or come in before or after school. We'll gladly explain anything you need explaining. I know the work here gets kind of confusing because there wasn't very much room. If you need me to break it down for you, I'll gladly do that. I tried to show my steps as best I could. Almost done. So 31 is kind of like the internal energy. In this case, you were looking for heat. And it was positive because you're adding heat. 33 is a really good one to look at. As you can see, your total energy stayed the same, and your potential energy decreased because your height decreased. Your kinetic energy increased because your potential energy decreased. And then manipulating, I even showed how to manipulate to get to V by itself. So hopefully that helped with a few people that are having trouble with manipulations. And then here's your convection, conduction, radiation. Here's your 4 laws. And then the last one's 0. 41 steps through all 5 steps. But remember on the test, we're going to go backwards on that. And then I think the most important question is 42, because if you know what variable goes with what unit, you're set. Now the symbols, that's when I say variable, I mean the symbols. So that's what letter is in your equation and what letter represents that number. And then, what the name of it is, and then your unit that correlates with that symbol. This is very important. I would know this because this will save those butts, I promise. Another thing on your test, we're going to ask y'all on the free response part, we're going to ask y'all to do your givens, equation, substitute, solve, and make sure you put your units right on the board again. These quiz grades are doing awesome, so we're going to harp on that and think that just helps you organize your thoughts a little bit. So I am going to ask you to do that on the test also, but I'll write that on the board to remember. Again, I hope you have a wonderful day. Happy studying. See you on the day of the test. Bye.